This chart shows a single hardware company's annual revenue. In 2022, it was $26.9 billion. By 2026, it spiked to $215.9 billion. That vertical line pushed its total market capitalization to $5 trillion, eclipsing almost every historical monopoly. The architect of this expansion is CEO Jensen Huang, who guided the firm from a niche graphics card manufacturer in 1993 to providing the primary hardware for every major cloud provider and AI developer on the planet. Clearing net income margins over 50% at this scale defies the basic economics of building physical components. Making physical hardware is usually a brutal race to the bottom, where competitors constantly undercut each other with cheaper, mass-produced chips. Rivals like AMD and Intel, along with the custom chip divisions of Amazon and Google, have the capital to design and manufacture their own processors. Yet titans like Meta, Microsoft, and Oracle find themselves completely locked in, buying this specific hardware at astronomical premiums. This market position is the result of a software infrastructure NVIDIA began building 20 years before the AI boom began. In the 1990s, the company was building graphics processing units, or GPUs. These chips had one specific job: rendering millions of individual pixels on screen for video games. A standard computer processor, a CPU, executes a few complex tasks very quickly in sequence. This diagram illustrates how GPUs differ. By employing parallel processing, a GPU handles thousands of simple mathematical tasks simultaneously. Modern artificial intelligence and deep learning networks operate on the exact same principle, relying on massive waves of simultaneous mathematical equations to identify patterns in data. By making digital worlds look sharper, they accidentally engineered the exact processing architecture required to build artificial intelligence. In 2006, Jensen Huang made the decision to release a specialized platform called CUDA. This abstract model demonstrates CUDA in action. It is a software layer that lets developers program those gaming GPUs to perform general-purpose computing and scientific math. Between 2016 and 2023, deep learning researchers adopted NVIDIA chips because this software interface made the raw power of the hardware accessible for AI training. While the tech industry was looking elsewhere, CUDA became the universal language of AI researchers, creating a foundation that rivals could not easily duplicate. Today, that dominance is enforced by advanced physical architectures like the Blackwell and Rubin platforms, which reduce the operating costs of running AI inference models. But the real barrier is what economists call switching costs. Even if a rival manages to build a chip equal to Rubin, that rival chip cannot run CUDA. To abandon NVIDIA hardware, a tech company would have to rewrite their entire custom software ecosystem, an undertaking too expensive for even the largest companies to justify. This software lock-in is the direct reason their data center segment alone pulled in nearly $193.7 billion in fiscal 2026. The software ecosystem makes the physical hardware inescapable. Their vision has now grown far beyond simply training chatbots, pivoting toward architecting the core computing infrastructure for the physical world. The outlook for 2026 to 2030 targets agentic AI, autonomous vehicles, scientific research, and advanced robotics. Heavy investments are flowing into industrial applications and digital twins, which use artificial intelligence to simulate physical manufacturing facilities before they are built. They are positioning themselves for a cycle where every physical industry eventually replaces its legacy computing systems with their architecture. Yet, a major physical vulnerability remains in their supply chain. They must rely on TSMC to manufacture these highly complex chips. Furthermore, if major cloud providers reduce their capital investments in AI infrastructure, this explosive growth rate will see a sharp correction. Ultimately, the company has successfully captured the entire vertical AI stack, from the software libraries and networking to the chips themselves, positioning them as the inevitable partner for the future of computing.